Hello, everybody. We're going to get started in about 30 seconds. All right. Welcome, everyone. Thank you for joining. I'm really excited about today's meetup. I try to use SVGs in like every single front-end project I do, just to everything should be in SVG format anyways, but just add that extra kind of interactivity, really like beautiful elements to your UI. So yeah, we're joined today by Paul Cowan, and we were just going through. He's written 23 articles for LogRocket over many years, which is great. And if you want to see his posts, he's got some very great opinionated ones, and also some stuff on React SVGs, and a lot of useful, awesome stuff. And yeah, I'll have him introduce himself a bit more. But Paul, seems like you're still doing a lot of consulting and a bunch of open source contribution, and still writing some articles for us. So yeah, this will be recorded and sent around. If you have any questions, just message us in the chat or in the Q&A. I'll maybe interrupt Paul, but maybe not if he's in the middle of something. But yeah, this is meant to just kind of like get in depth into this topic and maybe into some specifics here. But today we're going to be working with digital diagrams with SVGs using React D3 and BizX. Did I pronounce that? Sure. Mm-hmm. So yeah, looking forward to it. Yeah, today's meetup is brought to you by LogRocket. If you haven't heard of LogRocket, we're not just a blog. We have an amazing product for understanding how people interact with your applications, your websites, your mobile applications. And I use LogRocket every day actually to make sure all the dynamic and animated SVGs that I'm kind of putting all over the web are rendering correctly, rendering how I expect them, making sure they don't affect performance too bad, and a ton of other just really great ways to monitor your applications, making sure they're functioning properly and people are happy with what you're building. We've got some upcoming meetups on March 9th, so that's a little less than 2 weeks away. Graceful error handling in React. Over the last decade plus, just how this happens, this has changed a lot. So Andrew Evans is going to go through that. And we've also got optimizing application performance with React in React apps too. So yeah, you can sign up at blog.logrocket.com/techmeetups. If you have any feedback, shoot me an email at luke@logrocket.com. And I'll shut up now. So Paul, take her away. I can see you.
Okay. Yep. Okay, so I always start these by stating that I am Irish, and as such, I have an Irish accent. If I descend into vocal hieroglyphics, please stop me and tell me to slow down. So we are gathered here today to talk about SVGs and React. But first of all, why should you listen to me? I'm old. I'm 52. I've been around the block. I've worked on many different size websites, some big, some small, generally with a front end feel. But probably more importantly, I do a lot of open source. I still get a kick from getting my PRs accepted by well-known open source projects. And I do that much open source. I've even got my own open source section in my website. And currently I'm doing a lot of stuff in the Backstage, which is Spotify's developer portal. I'm very bullish on Backstage, but it's not really the point of this conversation. But I'm racking up the pull requests there. So I've been about a bit. Old developers have experience that the young developers just don't have. And recently I've been doing, as a way of helping my daughter understanding some maths, I've done some SVGs to, like, here we have a sine wave, and if you've done a certain level of maths, you'll understand what a unit circle is, and this is the relationship between the unit circle and the sine wave. Here we have a bit of calculus where we're drawing a tangent to a curve and another sine wave, because really one sine wave I find is never enough. It's better to have two. And rounding off with some tan isotopes. So I think it's important though to actually, I'll take a few minutes if you'll bear with me to actually let's really understand what this acronym stands for, because I think this it's got lost. Scale, so the Wikipedia definition is an XML-based markup language for describing two-dimensional based vector graphics. And like, that doesn't say anything to me. I don't really know a lot about that. What does scalable mean? So this is really why SVG was the de facto standard for charting, and still in a lot of ways is it has an intrinsic scalable nature. It doesn't always scale just out of the box. So the approach I take generally is to put my SVGs into in a container inside an HTML element and scale the SVG to the maximum width and height of that SVG element. And we'll go into that later, but all these diagrams will render, I would say, rather nicely, no matter what device. But it didn't come for free. It doesn't just magically do it. There's a bit of elbow grease, and there are two properties of an SVG element that are extremely powerful. So that's scalable. The vector, and this really gives the game away about why SVGs are good, and also it does show their limitations. So again, the Wikipedia reference of what vector graphics are is visual images created directly from geometric shapes defined on a Cartesian plane, such as point, curves, and polygons. And again, what, like that's not. But if we do break this down, we can see the geometric shapes, and this is what SVG is all about. You're creating lines, curves, and circles, and depending on what you're doing, if you break your problem down into line, curves, circles, and geometric shapes, then you really will get there if what you're trying to visualize fits into that paradigm. And you can understand why the charting has been so popular in SVGs with rects, and you can see how a line graph here, and we'll do a small one soon to show just that is the crux of the vector. A vector, if you've done any level of maths, is actually it's a displacement from one, like here we have a vector from A to B, we're moving 2 units to the right and 2 units up. So it's something with a size and something with a direction. And a lot of times when we're doing our SVGs, we are doing just that. We're plotting, we're plotting on a Cartesian plane, and a Cartesian plane is a fancy name for a 2-dimensional surface that extends indefinitely. And the one you might be familiar with if you've done, this is coordinate geometry, where we have an X and Y axis, and it's quite nice to be able to place plots on a nice axis. And if you're a web developer, you may be aware of a Cartesian plane that you've used, and that would, of course, be the browser viewport, or the surface that you place your HTML elements. And if you've been doing web development for any length of time, you will have placed HTML elements using top and left. And here we can see that actually the difference, the browser coordinates start at the top left. So the origin, or the zeros, are found at the top left and move to the right and down. So you use top and left. But wouldn't it be nice if we could create our own Cartesian plane or coordinate system that we can, let's say, for example, I don't know, a 10 by 10 grid. So it's much simpler if I can place a grid at, I can place a geometric shape at 5, 5. If I go back to the browser viewport, if I was to try and find the center here, I'd have to use percentages or a bit of maths. I'm no way am I going to find out what the exact pixel is at that spot in the browser viewport. So what we want to do is to create our own coordinate system, which is based on the browser viewport. And as chance would have it, D3 comes with what are called scales. We can create our own coordinate system by using what's called a scale. So a scale maps our own sort of imaginary coordinate system to the real width and height. And here I have a scale for the X for the horizontal and for the Y for the vertical. And I also, this is a hook I've created, which uses a resize observer, which is a new feature of the browser. So I have my SVG in a parent container, and the SVG will expand to the maximum width and height of this container. And I can do a lot of nice things if I know the width and height of this container. And that's what this hook does. It has a resize observer that fires whenever the browser resizes and will give me the dimensions of an element. So it's very, very, very useful. But here I've created an X and Y scale, which really looks like, which is based on the real width and height of the browser viewport. And then I can then use this simpler coordinate system to place elements. So if I was to place a SVG circle, so an SVG circle has CX and CY props where we put the origin of the circle. I can say X scale 5, and it will give me the actual, so it will map the 5 from my domain to the real width. And I'll do the same for the CY property. So that's Y scale 5, and we'll give it a radius, again, based on our nice friendly scale, or we'll use the horizontal scale to 1. And there you can see we have that is a piece of cake to position our nice SVG circle bang on the center. The crosshairs of our rifle are lined up, and it is perfectly placed. And we can move it about to our heart's content. We can make it bigger, smaller, etc., all based on our scale. So already things have gotten simpler. If we can break our problem down into these geometric shapes, if we have a nice coordinate system, then we can move things about quite nicely. So I did mention in our bit of self-promotion that I'm big on open source. This is a component that I actually added to Airbnb's VisX library, and that's a polygon. And a polygon has a number of properties, one being, arguably the most important, being number of sides. I can say I want a triangle. I can give it a size. And I can give it a center, the origin of the polygon, which takes X and Y coordinates. And there we go. We have a triangle, but we could just as well have a square, or we could have a pentagon, and we can rotate it. Yep, we can do all sorts of things like that. So if we think back to our definition of what an SVG is, it's about geometric shapes on a Cartesian. It's a geometric shapes, lines and curves. So those are geometric shapes. We can really sort of build those up. And another nice component that comes with VisX, which renders an SVG path, is this line path component. And we can think of a line path as really putting a pen down on a bit of paper and drawing some lines. So we give it some coordinates. Let me give that a better color. So we can think of, again, we look at our coordinate system. We can think of this as really being able to draw any sort of geometric shape here. In fact, let's close the triangle off. And we've got these nice properties here, this X and Y, where we can give it a function. We can give it an X and Y, and then we can call the scales to make sure that the lines are positioned perfectly. And we can also, there's a curve property of the line path where this will cross off the curves part of the SVG definition. So if we create another line path, let's just delete that for now. So if we don't give it a curve property, then we draw the lines. They draw up as the crow flies. But we can give them a curve property. And with that curve property, we can describe how we want the lines to be joined up. So that's a curve natural. There are several at least of these things. This one, I would say, is actually going beyond. This isn't a curve, so I'm not sure this is quite allowed. This isn't really a curve, but the point being that there are a number of ways of drawing these lines up. And you can really see how that this is why a lot of the charts are built with SVGs, because of their scalable nature makes them perfect for the web, and the ability to most charting is a collection of geometric shapes, lines and curves, and we can even there are some helpers for drawing axis in both D3 and VisX. So I can place an x-axis, so that will be an x-axis bottom, and a y-axis, and you can see, and I can do so. By default, it would have used the values for the x and y values on the axis would have been the domain, but there are helpers for things like format where we can change them to whatever, and I certainly use that in my diagrams to draw the math jacks or the math symbols. And we can use rects as another geometric shape we can use, so you can see how easy. But VisX has a lot of helpers for drawing charts. Generally, you won't need. There are many good charting libraries built on top of React, but I always find there's some requirement that creeps up where I have to go outside the bounds of the charting library, which is why I like VisX. It's low level enough. If I use something, there's another library by Formidable, which is really good, but there's no real escape hatch. If you need to go outside the bounds of the API, you're a bit stuck. Whereas with VisX, these are nice. It's a lower level abstraction where I can build things up. And you can definitely see why it is quite easy to start constructing your own graphs. If we now go back to and have a think about animating these charts. So I take the same approach with animation as I do in all. I have what I would call a tick, and a tick like a clock ticking, and every time the clock ticks, the shapes move. And to achieve that, I generally have a counter of some description. I'll use state here, and then I use request animation frame, which is, if you're not familiar, which is a browser function where you ask you give it a callback, and the browser will decide when the best time is to run that callback. So I'm going to use a combination of React's infamous and often misunderstood use effect, and request animation frame. It's not going to do any animating. All it's going to do is to move the counter, but it's going to do it at a time when the browser thinks is the best time to animate things. Let's bring that back. Bring that back. And so now we have this counter, it's constantly ticking. So with that, I can actually, and what it does is, all it does is it increments by 2 each time a guild gets to 200 and then resets to 0. And then I can start using this I can start animating the size of my polygon. I could do the same with the circle. They control the radius. So the the rectangle is not left out. We could even use it to rotate the polygon as well. So this is how I do everything. Even I can call trigonomic functions, but it's all based on this tick. So here, as the circle goes around, it's all based on this tick, and we can actually control the speed things animate as well. So if I make that a nice one, slows down. If we don't like our users, we can maybe freak them out a bit. But let's not do that. And really, the point I'm making here is that it's this tick. It's this tick and getting things to move about. Again, it's all about breaking problems down to geometric shapes, and if so, applying animations on them. So that's going to get quite annoying quite soon. So let's get rid of that. And let's again move back to the scalable nature of SVGs. And there are 2 attributes of the SVG. As I stated before, you might be lucky and your SVG document will just magically scale. I've never been that lucky. The more complex it is, the more the browser would need some sort of telepathy to actually understand how you want to scale. And these are 2 important tools, or two important weapons in your armory if things get out of shape. And the first is the view box. And the view box is simply 4 numbers, but I don't think I can think of a more powerful attribute where more is possible with 4 numbers than the view box. The 4 numbers are min x, min y, width, and height. And the first 2 numbers are not as powerful as the last 2, but they can control what's called panning, and that is the ability to move things left and right. So again, use our scale. We can move things if we increase the scale, it moves left. That reminds me of increasing a quadratic function in math, then it always goes the way I don't expect it to. And we could do the same with so we can control left and right with the first 2. The next 2 control zooming. So we can zoom in and we can zoom out on our SVG document. And how this is possible goes back to this ability of creating coordinate systems. So I first of all said we have the browser coordinate system, which is like a vast universe of millions of pixels that the mind can't comprehend and reels back. And then we have our nice friendly SVG coordinate system. We have at our disposal a third, and that is the view box. So if the SVG width and height is the same as the view box width and height, then there's a one-to-one mapping, and nothing changes. If, for example, what would you expect to happen if we double the view box width to the SVG width and height? I was quite surprised when I first seen this, and that was we increase the size, things get smaller. So we've zoomed out. That came as quite a shock to me, and the reason that's happened is because we've actually created a new coordinate system based on the SVG viewport that has scaled out. I'm not sure that's right. Honestly, if scaled out is wrong here, somebody correct me, but I think I'm going to say this is scaled out or scaled up. So we can see that our new coordinate system is half of what the old one was, and the image has scaled right back, which is very important for resizing things in the browser. And conversely, if we make things smaller, we zoom in on our SVG, and we have, you can see now, from our 10 by 10 grid, we actually have a 5 by 5 grid, and we have got we've zoomed right in on the document. And I've seen some really complex things where you're able to zoom in and pan left and right, and you could do all that with the view box. It's a very, very, very powerful attribute. The other thing we have here is this lesser known preserve aspect ratio, and you generally won't have to use this, but it is good to know it's there. So I've actually created a nice TypeScript type here, using the lovely features of unions and string literals, because I could never remember these values, and it is actually a plain string in the SGV, unfortunately. So I've created a nice TypeScript type here so I don't have to get this wrong. But so what generally, so this is about aspect ratio, and for those who don't know, aspect ratio is the ratio of width to height, and we can see here the ratio of width to height is good because our circle is perfectly formed. But if somehow things were to get a bit skewed like that, then the aspect ratio has gone wrong, and we no longer have a perfect circle. And this is where preserve aspect ratio comes in. This can save your bacon in these circumstances. So at the moment, I've got this set to none, and none is not the default value for the for preserve aspect ratio. And in fact, if I remove that, you can see that our circle is now suddenly aspect ratio has been corrected for us. And this goes back to this, that SVGs have these intrinsic scalable nature. SVG has our back for these situations. So and that's because the default value for preserve aspect ratio is rather esoteric or cryptic. Xmid y mid meet. I mean, whoever come up with this API deserves a good pat in the back. It's xmid y mid meet, and meet. So we got meet and we have slice. I've never used slice. I'm sure there's a time when you need to do that. I've not reached it yet, but meet means that you will get the whole document. We have a whole plethora of various values we could use here. But generally, the default will be enough. But if you do get into problems with aspect ratio, then preserve aspect ratio is your friend. So I've used a combination I've created a component that is really, I don't even need to think really about responsivity anymore. I created this response, I called it responsive SVG. BS Code always puts the wrong import in for my stuff. Maybe something wrong with my stuff. And all we have to do is give it a width and a height, which is coming from my use parent size hook. And then I find that the thing, it'll just what I do in responsive SVG, there's a bit of browser trickery here. I'm setting the height to 0 to make sure aspect ratio is maintained. I set the SVGs width and height to be, these are probably browser defaults now. I'm not sure, certainly height auto is, but I'm not sure if I need to set these, but I set them to the maximum, and then I create a view box with the width and the height with respect to aspect ratio, and I find that's just cured practically all my my responsive needs. And with those tools, I mean, with the ability to break. So what's SVG not good for? SVG is certainly not good for doing things in 3 dimensions. That's, you probably could, but you're going to get much better on with WebGL. I think this is not what SVG is good for. What's React and SVG is not a good match. If you're creating thousands of elements, then React is not going to make this faster. So you might want to just use straight up D3. But I think you can get quite far with and my unit resolution is to get into WebGL. But with the combination of geometric shapes and responsivity, you can get quite far. It all depends on what the problem is. We can, so one thing we need to be aware of, certainly we give a quick shout out to LogRocket, or in fact, I mean, as a consultant, one of the things I always advise is to monitor what's going on in the browser, because it's not like server-side code where it's easy to track. The browser can be a black box, a Pandora's box of hidden pain if you're not careful about what's going on in user machines. So we really want to track this stuff, and certainly LogRocket has some really good stuff for monitoring CPU, because we could have our UI threads. So we can have our UI threads just totally dying on us, and will we not oblivious if we don't use something like LogRocket. So even I'm a consultant, so I always advise you need some software to track what's going on the user's out of your eyesight. It's very important. So LogRocket has certainly some of the great stuff for tracking performance, because if your SVG is running out of control or your use effect is constantly firing, then your UI thread is dying and your user's machine is dying, and that's not good for anybody. And that's really all I have to say about that. I have an example repo here. I'll link to anything I have mentioned so far with the email I'll go out tomorrow, and I will leave it at that, and thank you for your time.
Awesome, thanks, Paul. Yeah, I actually sent out your post from 2 years ago on the responsive React component for SVGs. Yeah, no questions so far. I actually had a couple. Yeah, you always forget that the viewport is a graph. It was a really nice way to actually demonstrate that, like the browser versus SVG viewport versus viewbox. I've never seen that all in one place. Like, I was like, oh yeah. For VisX, like I do a lot of like designing SVG patterns in Illustrator and then port those to the web, which is probably not the right way to do it. Maybe it is. Like, do you have to be making SVGs within the like VisX pattern, or can you kind of like mold stuff into it and use all those options?
No, it's just for anything. I mean, generally, it seems if you're
Yeah.
doing charting, there generally are lots of good. There's tan stack charting and stuff we use recently. You generally won't need this. It's really for the occasions where the requirements don't aren't possible within the charting library. That's when I would reach for VisX. Yeah, it's definitely not the norm. It's not the norm. But I think it's because the charting libraries are really good now. I mean, you really can get far without them. It's just there's always one requirement I find if I'm doing that I just can't do in the charting library. So that's when
Right. Okay.
It's the exceptional cases.
Good. So that it sounds like that's kind of a really good example for it. Cool. Arthur asks, do you have a preferred tool or method for creating SVG sprite sheets?
I don't know. I don't. It's not something no, I don't. Not something I've really done a lot of, to be honest.
What is a spreadsheet?
Oh yeah, there is actually. I know what you mean. So it is. Yeah, you can like. Yeah, there is. I can't remember the one I used actually. There's a way of like getting SVG icons. There's a number of paid services. That's what I used last time anyway. That's what I'm thinking of anyway. I can't remember the name offhand, like, but it was just slice and dice it. It was a paid service.
Like the icon libraries.
I can't remember those famous ones. Yeah, exactly.
And then what was it like? Like obviously, like a polygon getting included in that library was like no one's going to argue with that. But what was the process like getting that kind of?
Actually, so
yeah.
No, it was actually quite good. I can't remember what sparked it. But yeah, that was actually okay. That was well received. That pull request, so it was, it's definitely useful. So
yeah, do you run into anything weird as you were trying to?
It was creating hexagons. I was creating hexagons, and I couldn't find anything anywhere to do it. So yeah, it was the hexagon. It actually did start out, I think it's a hexagon component. But then I realized that if you just use the 180 degrees times the number of sides minus 2, you can get the angles for the polygon. That's how it works. So the polygon was born. Yeah.
Awesome. I think that was all the questions, but yeah, this was great. Oh wait, we got one more that just came in. Just a thank you, not a question. Yeah, also I didn't know you could unset the preserve aspect ratio. I think that's really helpful if you're doing
it's rarely you're gonna have to do that. That's who came up with the name X mid Y mid.
Yeah.
That definitely doesn't give the game away. I don't think it's very, very esoteric. But yeah, if you ever do, you never know. Tomorrow you might have the opportunity and you'll know what to do.
Yeah. And someone asked, like, did D3 actually play a part in what you were showing today much?
Oh, VisX. So VisX, I mean, most of the D3 is like almost like assembly. Yeah, so VisX uses D3.
Okay, so it's like an extension of it.
Yeah, it's like React components and hooks on top of D3. Right. I'd say 90% of the charting libraries, if not all the charting libraries, use D3 in some description.
Right. Cool. Awesome. I think that was it. Another thanks, and oh yeah, interesting. Just like moving from After Effects into like web world. I think this was pretty useful if you're at that. So awesome. Thanks, Paul. So yeah, like I said, the recording will get sent around. Go read Paul's posts. They're awesome. If you have any questions that come up, shoot me an email. But yeah, thanks for joining, everyone. See you next time.
Cheers. Bye.